All right, so yeah, I about to just do some leak code here. I was thinking about this problem just beforehand. I've also solved it, but it was probably a while back since when I solved it, February 2023. So I already gave it some thought. I think I have an idea. I don't want, bore you guys with just me thinking here, but then I'll explain my thought process and what I'm thinking here. So let's just read the problem. You're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I and 0 and I at height of I, which is fine. Okay, so each one of them is like, it's kind of like a grid with only using just one dimensional array here. Find the two lines that together with the x-axis form a container such that the container contains the most water. Let me see really quick. My mic is on. Okay, cool. Return the maximum amount of water in the container of a container can store, and notice that you may not slant the container. Okay, so cool. So we're just taking the it multiplied the number that we're looking at multiplied together will give us the area, and we want the maximum amount of area. Kind of already just looking at this, right? And the fact that I got it from LeetCode and it said two pointer. I'm assuming it's two pointer, but like if I wasn't in a situation where I didn't know, or if I was in a situation where I didn't know, I would have just kind of assumed that we, when I kind of see like you could kind of brute force or you kind of want to find either like this kind of sliding window type of thing. I always initially go with two pointer and then I think about sliding window. Um, and this could possibly be a sliding window problem too. Maybe, but I think it might be more of a two pointer because the sliding window, you need some sort of true condition to kind of keep your window valid. And in this case, and it maybe be like better if it was like maybe something sorted, like a problem that was sorted, right? And you can somehow keep your window valid. But I think in this case, it's just two pointers, and you just want to know when to move the left or when to move the right. And so I was giving it some thought, right? Let me just switch the song that I'm on 1 second. So I was giving it some thought and I was thinking, okay, maybe we move the pointers depending on which one is less than the other, right? And so for example, right, if we have the left pointer is smaller than the right pointer, well, we probably want to move the left pointer, right? And that's because, and sorry, let me explain myself. When I say smaller, I mean the height is it's tinier than the right, and so therefore we probably want to move the left pointer just because we want to grab and maximize the largest amount of area. And although you can do that with really small, super spaced out, right? In this case, we'd probably just want to go for, um, the highest one, and then also the most spaced out. So that's our essentially our condition of how we're gonna move these pointers around. And then from there, why if we ever meet the middle or we ever if left is ever greater than or even equal to right, then we kind of return right our max that we've gotten from this up to this point, right? And so I'm sure there's probably some greediness here as well, but that's what I'm thinking here. So let's go ahead and try that out, right? And so let's one of our conditions was move the pointer that is smaller, right? And so again, before we even start, let's talk about what brute force would be. Well, brute force would be, starting at index one, checking every other index and see what's the maximum solution there, that moving to the next, and then doing that over and over and over. And that could work absolutely. That'd give us a time complexity of O of n squared. But we would probably just want to go for the optimal solution. So let's try this out. If it doesn't work, then you know what? We'll just go back to brute force. That's what I would. That's what I think. We'd take the L and just kind of go for that. All right, cool. So let's try this out here. So we're gonna make a left pointer, and we're gonna start them at the ends here, and we're gonna make a right pointer, which is going to be, and I'll just change this to H here. Um, so we're gonna do the length of h minus 1. And so what we're gonna do is we're gonna go while L is less than R, we're gonna keep moving right here. And then the first thing we're gonna need is to grab some sort of max, right? And so the max that we could say is just gonna be 0 to start off with. And then at the end, we're gonna return M, right? So that's what we're gonna essentially do. And then what we're gonna do is super simple, right? We're gonna say, M is equal to, what's the current, what is the current like area that we're covering, right? And we said that an area would be something like this. Well, we're going to take the max and we're going to take M, whichever is more, right? And we're going to say, well, while H at L uh, times H at R, oops, sorry about that. So while H at L times H at R, take whatever the max is there, whether it's M or HIL, HRR. In this case, it's going to be, of course, this first iteration is going to be, it's going to take the, what HL and times HRR is just because it started at 0, but whatever. And so what's going to happen is essentially we're going to now check, well, which is smaller, right? Because we now need to know which one to move. And so we need to check, well, what is smaller? And so I would say just by checking, H at L, if that is less than H at R, if that's less than, um, and I guess if they're both equal to, then just move. If they're both the same, then just move whatever. So I'll just do an else clause here. But if this is true, then we're going to go L plus equals 1, else R plus equals 1. And then at every single time that we're checking this, we're then checking, what is greater. I'm sorry, let me repeat myself. Every single time we're checking if what is less than the other, right? And then that's the pointer that we're moving forward to try to advance. So let's go ahead and just run this in this kind of not to submit just yet, right? And let's just see what we're working with here. So it's telling us we're getting a list index out of range here. So that's happening here. And so let's kind of verify this here. H, the length of H minus 1, which is R, and and then H at R. And then what is the out of range here? Are we talking about? Let's just print. Let's do some debugging here. Let's print out H and R, or L and R, sorry. So we have, oh, I'm sorry, that is not it. That's a minus. Sorry about that. Let's try that again. Okay, cool. So looks like we passed the first case, the easy one, but we did not pass this one because we got we got 64, and that is because that's just not how you actually calculate the area. I'm sorry about that. Because we're forgetting the fact that, right, 8 times 7 is 56. Oops, I'm so sorry. Where's my, dude, we can't type 56. Yeah, so I'm sorry. That's not how you're calculating the area. We're calculating the area by, um, how do we calculate the area actually? Oh my gosh, math, huh? Max area. The area is calculated. Area is length times width, right? And so I'm so sorry. Yeah, I'm an idiot here. The height is gonna be the highest one that's up. Yeah. I am a dummy. So what we're going to do is essentially take which, oh man, we're gonna need to know which one's actually bigger, I guess earlier, right? We're gonna need to know which one's, because we're gonna need to take the smaller one to get the max. So I guess if we like, I don't know, let's just try this. I'm gonna give it a shot because now we know for a fact that, right, we know for a fact that this one's the smaller one, and so we'd want L to be the length times the width. So we'd want this one to be the length, I guess, if we really want to say. So L is going to be the smaller one times the width, which is just R minus L, I believe. Now, I don't know if this is plus one. I think it is. And so I'm going to do that. And we're going to want to do the same thing here, but with this guy being R here. Now, I don't know if that plus one is correct. But let me just double check here. Okay, now I'm actually getting 56, which is weird. I don't think, yeah, because it would be, would want R and then L minus, so it's the length of that, right? Yeah, there it is. So I guess, okay, I guess I was probably hitting the 8 at that point, right? So I was getting it wrong there. So that seems right. Oh my gosh, I could not calculate the area. I need to write that down for some reason. I totally forgot how to calculate area. Area equals length times width, of course. And then let's just see if that actually worked. And that's interesting that that's okay. First of all, that's interesting that this actually worked. One thing that I'm a little confused in, just kind of describing still my not understanding of all this. I find it interesting that we move. Oh, we choose. Because I know I kind of said it, and it's probably because my mind from 2023, just remembering this. But it's like it's interesting how we completely, when we move, we completely um what's the word? We completely say that this is not. Oh, I get it. I get it. I was about to say, like, we completely say that this is not in our solution set anymore. But that makes sense though, because if this is not, because I was thinking to myself, I was like, oh, what if this right here with some other combination could work, right? But the thing is, we're only ever talking about what's inside, not like anything previous or anything previous over here. Or even if there was some stuff over here, right? Um, this will only ever be as big as it is itself, right? So the water will never be bigger than this because it would overflow. And so my thought process here was like, oh, well, if we had a couple ones that are over here that are bigger, um, or bigger or even the same size, then, wouldn't, what if this area is more than, what we currently have here, right? Pretend there's some other pillars here. But the thing is, we would have reached this one because if this one, let's say, was big, right? And it kept beating everything, before this, and it got to this one here, right? Because I don't know, let's say it was bigger than all these ones previous, right? Um, then either we would have found, because one would have been bigger than this one, or this one was the biggest one and we would have found it here by staying there. Yeah, so I'm sorry, I just kind of wanted to think that through really fast to make sure I fully understand what I'm saying. But yes, so this is just this two-pointer solution. I literally goofed up on the area, but it's fun. I think it's pretty cool. All right, thanks guys.